In exercise 7C, we have two smooth spheres, both of mass 2 kilos, colliding obliquely, and their velocities before impact are 4I plus 3J and I plus 2J, where I is along the line of center. So this means that J remains unchanged, the J velocity, when I is along the line of center, and we're told the coefficient of restitution is a third here. So we put the masses down as 2, and we see what's happening before and afterwards. We have 4I plus 3J. We have I plus 2J. Afterwards, we're going to have AI plus 3J, J remaining unchanged, and we're going to have BI plus 2J. For the second one, we could call them P and Q if you want to give them letters. So let's apply our two formulas here. So conservation of momentum we'll do first. So our 2 by our 4, this 2 by this 4, or this 4 by this 2, plus our second 2 by the 1 that's in front of that I. That would have to be equal to the 2 times A plus 2 times B. So 8 plus 2 is 10, is equal to 2A plus 2B. Newton's law of restitution, V1 minus V2 over U1 minus U2 equals minus E. We'll have A minus B over 4 minus 1 equals minus this 1/3 here. So 3A minus 3B is equal to minus 3. Looks like A minus B is equal to minus 1. And down here we can divide by 2, or bring it up and divide by 2. Just write down what we're doing. We're dividing this one by 2 to get A plus B equals 5. Adding the two lines together, we're going to get 2A equals 4, so A equals 2. And if A equals 2, we can say 2 plus 3 equals 5, so this B is equal to 3. So we have our new A is 2, so we have 2I plus 3J here, and B 3, so we have 3I plus 2J down here. We're asked for the new velocities, they're the new velocities, and the loss in kinetic energy. So the loss in kinetic energy, half mu squared. So we need the magnitude of these velocities. So at the beginning we have 4I plus 3J, so the magnitude of 4I plus 3J is 5. You can see that. And the magnitude of I plus 2J is equal to root 5. So half mu squared becomes a half 2 times 5 squared plus a half 2 times root 5 to be squared. So that's going to be 25 plus 5, which is 30 joules. That's what's happening before. Afterwards, we have a half times 2 times the magnitude of this guy is going to be root 2 squared through root 13, and same with the second guy, root 13. So a half m by root 13 squared, I'll just put the 13 in here, plus a half 2 by 13, so that's going to give 26. The loss of kinetic energy, 30 minus 26 for joules for question 1. On to question 2. The masses are 2 and 3, 2 and 3. Before we have 3I plus 4J. So afterwards we're gonna have AI plus 4J, and the second one is minus 4I plus 3J, and then we'll have BI plus 3J, no change in the J. We're told coefficient of restitution E is this 3/7, and I is along the line of centers, so that's why there's no change in the J, and we're looking for the velocities after impact. So conservation of momentum, 2 by 3, this 3 being multiplied by the mass, and similarly below the 3 by the minus 4 plus 3 by minus 4 is equal to 2 times the A plus 2 times the B. So we're going to get 2A plus 2B is equal to minus 12 plus 6 minus 6, or A plus B is equal to minus 3. If we use Newton's law of restitution, V1 minus V2, we're going to get A minus B over 3 minus 4, which would be 3 plus 4, these two U's, and the two V's, equals minus E minus 3 over 7, 7A minus 7B equals minus 21. So we're going to have A minus B equals minus 3. And from below we have A plus B is equal to minus 3. So we're going to get 2A equals minus 6. So A is equal to minus 3. And if A is equal to minus 3, that would mean that B would have to be equal to 0 here. So our new velocities are AI minus 3I plus 4J, and B is 0, so we're going to get 0I plus 3J. Then we're asked for the loss in kinetic energy. So the magnitudes, you can see both of these are 5 here. The magnitude of this one and this one, 3 squared plus 4 squared, square root of. And the magnitude over here is still 5, where you have a 3 and a 4. And down here it's just going to be 3 because we have a 3 and a 0. So a half mu squared is a half 2 by 5 squared plus a half 3 for the second one by 5 squared. So that's the kinetic energy before, which is 25 plus 1.5, 25 is 37.5, which is 62.5. And then afterwards we have half by 2 by the 5 squared, and we have a half by 3 by the 3 squared. So that's going to be 25 plus 1.5 times 9, which is 13.5. So that's 38.5. Difference between these two, 62.5 minus 38.5 is 24 joules for the loss in kinetic energy. And then the last part of this question, the magnitude of the impulse imparted to each sphere. So we look at impulse is mv minus mu. So we're going to have, we take the 2 first, we'll have 2 times, it became this minus 3i plus 4j, and then minus the 2 times what it started at, which was 3i plus 4j, and we should end up with no j here, minus 6i plus 8j minus 6i minus 8j. So we're just going to get minus 12i for the impulse, and the magnitude, Newton seconds, the magnitude we just say then is 12 Newton seconds. And if we just double check the other one, we'll have 3 by 0i plus 3j, 3 by 0i plus 3j. We're going to have minus 3 by minus 4i plus 3j, minus 4i plus 3j. So we should get a plus 12i here. So we're going to get 9j plus 12i minus 9j. So we do indeed get 12i for the other one. So we have a 12i minus 12i, and the magnitude being 12 Newton seconds.